Hello everyone, welcome back to BC Calculus. We're still in lesson number 38 where we're talking about polar graphs and we're doing polar graph discoveries. We've already discovered circles where the tracing is twice, so their domain is from 0 to pi. And then we talked about limicons, all types of the limicons, where it's either inner loop, cardioid, or dimple convex, and they're traced once. And let's now talk about our petals, our roses for these. For these examples, we just want to say, let's just graph them, because you don't actually need to know really what these graphs look like per se on these problems. We just want to graph them and look at behaviors of what's going on. So notice that the examples, this first four that you guys see here, all of my thetas are going to be odd. And you know that this is a rose because we have a number, there's no plus or minus, and then our theta actually has a number in front of it, right? If this had just been 2 cosine of theta, then that would simply be a circle. So let's graph these things, and this is from the previous video. Again, ladies and gentlemen, make sure that your graph has this little key thing right here for it, and I'm going to go ahead and just clear that. When you clear it again, I should delete it, but I do what I do here. So when you clear it, make sure you go back over here for this. So we look at 2 cosine of 3 theta. Now we've already discussed that since this is an odd, it's our odd theta, right? The number for this is odd. We know that we're going to only have 3 petals. Right, so we've actually had this discussion that we know that this is odd, 3, and that for our evens, we're going to have a double. So 2 questions we're asking ourselves. How many times do we circle through, and where does the graph start? So let's graph it. And there we go. Oh, there's 2. So we see that, right? So we start over here, and again, the radius is 2. We start over here, and we graph 2 times. So the other thing I want you guys to notice about this graph, and I'm just being really bad with them, being a very bad teacher here, is if you guys look at the graph for this problem, then notice that it's symmetric to the x-axis, right? So cosine, it's all symmetric to the x-axis. If I draw a line straight through this, it is symmetric there. So if I go ahead and do another one, let's look at this bottom one. So let's go to 2. Let's go to 2 sine. Oh, and it started right here. I was like, what's the other thing I was asking you guys? It started right here. So I'll get to that in a second. So let's graph this guy. Notice that it started at the pole. And it traced twice. Right? It traced twice. So start at the pole. So let's go ahead and change the colors up of this. So here it starts at 0, or actually at 2. And then here it starts at the pole. And ladies and gentlemen, just like before, this is with the circle conversation. If you plug in 0 here, you're going to get cosine of 1. 1 times 2 is 2. If you plug in 0 here, you can get the sine of 0 is 0. 0 times 2 is 0. So again, symmetric to the y-axis. Symmetric to the y-axis. So that's our summary for these. We trace it twice. Again, this is where we have an odd theta. This is an odd theta for our roses. And then what do we notice about our graphs? Well, a couple things about this. If it's a cosine graph, then we know that it's going to be symmetric to the x-axis. And we also know that it's going to start here on the pole, right? Or, sorry, on the x-axis. If it's going to be a sine of theta, we know that it's going to be symmetric to the y-axis. And it starts at the pole. So let's just really quickly make sure that that looks right for the rest of them. So let's graph the other 2 and just see if that makes sense to what we do here. So we have 3 cosine of 5 theta, and so we should assume that it's going to start, the radius of 3 is going to start over here. We're going to have 5 petals, and then we're going to see it repeated twice. That's our expectation for this. Let's graph them and see. It goes pretty fast, right? There's 1 full rotation, and then there's 2. There's 2. So again, symmetric to the x-axis, and started here, and then rotate it twice. And then the last one, ladies and gentlemen, on this problem, it's going to be 3. We're going to do sine, just to verify it, graph. And we could slow this down, but we don't need to worry about this right now. Notice that it's symmetric to the y-axis, it's repeating itself twice, and it started here at the pole. So this is good indication of what we need to do for these problems. So let's go down to the bottom, and let's look at the even functions and see what here. So we know that right now, because they're even, let me see up here. So odd, we did want to say something about this. So odd, for odds, it's equal to the number of petals. And so for even, you guys can see I'm really not organized with this no set right here, right? So even, we're going to double it. We talked about this in the last one. So let's graph this guy, see what we have, see what happens with it. See where it starts. See how many times it circles through, all that fun stuff. So we're going to get 3. We're going to do cosine, and we're going to change this now to a 2. So let's graph it. No shocking where we start that. Oh, and notice it went through one time. One time. So it started here. Again, I'm being such a bad teacher. The radius is supposed to be 3 for all of these. It doesn't matter. It starts right here, and it only circled through one time. So how many times does it go here? So if it's an even, then our cycle is going to be from 0 to 2 pi. If it's odd, then it's going to be from 0 to pi. I do want you guys to notice that up here we talked about symmetry for this. If it's a cosine and it's even, then this is going to be symmetric to both axes. Both axes. If it's sine, well, let's look and see what happens with sine. Let's see what goes on with that one. Just really quickly, let's actually look at this one more time. Let's try this one and see what this graph looks like. So again, twice is going to start over here, or here as we go with our graphs. So 2 cosine of 4 theta, and again, we're going to have 8 of these things. As you guys can see. And you guys are not responsible for knowing like what petal goes in what direction, right? So we have 8 petals. It's symmetric to both the axes. So that's a clear indication that it's going to be cosine. And again, it just went one time. So let's look at this one right here. We're going to have 3 sine of 2 theta. And let's graph that one, see what happens with it. So again, it starts at the pole. There's no shock with this. We know it's going to have a ratio, 4 petals, and so it's not symmetric to, it is still kind of symmetric to both the axes, but it doesn't cross the axis. Like this is still symmetric to both the axes, but the cosine actually lands on the axis. This one does not. And let's look at this one and see what this one does. I can just really quickly put this right here. So not very much teaching here. We're just like, this is a discovery. So we're just kind of playing around with this and seeing if it's the same thing. It is. So graph this thing and see what this graph looks like. And again, just like before, guys, notice it's not on the axis at all. So it's still symmetric to both the axes. So we can go ahead and say that. This little pretty picture that we have here. So it's also symmetric to the both axes, but the difference between this is that the cosine graph is actually on the axis, right? It eats up the axis and the sine does not. So let's really quickly think about, well, which ones were the period from 0 of theta to pi? Well, those were circles, and those were odd roses. And then what happens with 0 theta to 2 pi? Well, those were the limicons. And then your even roses. And then, ladies and gentlemen, the easiest way for you to talk about like where something starts is just plugging 0 into your equation and see what the radius is. If the radius is 0, it's going to start at the pole. If the radius is any other number, then it's going to be that value. But actually, if we look at the sine, because that's the most important one, well, where does it actually start at the pole? It's going to start at the pole for our circles and for our roses. So circles, that's supposed to be pole. I don't know why I wrote polar. So let's change that up. And that's it, ladies and gentlemen. We are ready to actually do some calculus. You have hopefully a really good foundation now what the graph looks like. And so in the next lesson, we're going to talk about how to actually take derivatives and integrate our polar functions. So I will see you guys in the next lesson. Take care.